Hey everyone, this is Sebas from Nextmove, and today I'm going to be showing you our apps from models experience, in this case using the HiGHS. So for today's agenda, we're going to first create a decision model that solves a really simple knapsack problem. Then we're going to run it locally, make sure that it works. We're going to move on to then push it to a Nextmove cloud application, hence the name apps from models, to finally run it remotely. So let's dive right in. The first step is to install the necessary Python packages that we need. So we're going to be needing HiGHS, and we're going to be needing Nextmove. For Nextmove, though, in this experience, we need some optional dependencies that we're going to install by using the all keyword. Cool. So for the imports that we need, I already have this ready, but mainly we're going to be using HiGHS and Nextmove. And we're going to start by creating the decision model. So a decision model is any model that inherits from the Nextmove.model class. And it can be named whatever you want. In this case, I'm naming it decision model. And this decision model has a solve method that we need to implement. So the input is of type Nextmove.input, and it returns an output. So with this method signature, we need to pass it in an input, do something with it, for example, solve a problem, to then return an output. And to solve this classic problem, the knapsack problem, we can hop on over to our community apps repo. In there, we can find our Python HiGHS knapsack app. And in there, we already have an example of what it is to work with a custom decision model. So let me just steal that code. Okay, so what we're saying is that we are creating a new solver, defining some decision variables, defining a constraint, setting our objective function, then going over the solution to select the items that we picked for a knapsack, and finally constructing our Nextmove output. So we have that decision model defined. Now it's time to run it locally, make sure that it works. And the first step to do so is defining some options that the model might need. In this case, from our community app, let me just borrow these options from here. And let me fix indentation. There we go. Because we're working in a Jupyter Notebook, we don't really need the input-output, which is more for a CLI or terminal experience. In this case, we just need one option, which is the duration that we're going to use to configure our solver. Now we instantiate our model, which is simply creating an instance of my custom decision model class. There we go. So model variable already has my decision model. Now we need some input data. So we can take the sample input that ships with the community app. It's just a JSON that specifies the possible items for my knapsack and the weight capacity for it. Cool. Now it's time to run the model locally. We're going to actually make sure that it works. So the first step is to define a Nextmove input. This input has some data, which is my sample input that I defined, and it takes in the options that I also created before. Now, to get the output, we call our model.solve method, of course, by passing in the input that I just created. And we can, for example, print the result of that output or the solution, really. Let's execute that. Okay. So we know that our model is working locally, but now it's time to push it to the cloud. So to push it to the cloud, we need a couple of things. First, we need a cloud client. So this is a Nextmove cloud client that takes in an API key, and I already have my Nextmove API key set as an environment variable. We need a Nextmove cloud application. This application takes in a client, and it is identified by an app ID. So if you already have an app ID, you simply pass it in here. If you don't, you can go to the Nextmove Cloud Console and create a new app, or you can do that from the CLI. in my case, I already have an application created. So let me just take that ID and then I called it apps from models, HiGHS, sample. There we go. Kind of a mouthful. Okay. So when we are encoding a decision model and sending it to the cloud, we need to configure how it's going to be ran. So for that, we need an object named model configuration. Model configuration, there we go. This model configuration needs a name. So we can name it whatever you want. For example, HiGHS model, that works. This model needs some requirements to run remotely. And these requirements act as a requirements.txt file. So for the first line, we know that we need HiSpy. For the next line, we know that we need nextmove. And let me just check the versions on those. So HiSpy is 181 and nextmove is 014.1. So this is 181 and this is 014.1. Okay, and lastly, my model configuration needs the options that I'm working with. From the model configuration, I can create my app manifest, which contains further instructions to execute the app remotely. So this is a nextmove cloud manifest, and there's a convenience function that we created to create that app manifest from my model configuration that is ready. So I have everything that I need to be able to push. So with my application, I'm going to be using the push method. So I need my manifest. I'm going to give it my model, which remember is a variable that represents my custom decision model that I created in this cell. We're going to be needing my model configuration. And lastly, we're going to say, hey, give me verbose mode so that I know what is happening. All right. So this code will then encode that Python model and push it to the Nextmove cloud. And while this runs, let me just go ahead and fast forward to when it finishes. All right, so that finished pushing, and I can check in Nextmove Cloud that I have my latest pushed executable there. So because this model is already live in cloud, now I can simply make a remote run. So instead of running locally, let me just now run against the application. And we have this new run with result method that will take care of starting a new run and poll for results. My input is going to be my sample input, and then we're going to give it an instance ID of Devin. So every custom cloud application comes with a pre-provision or default instance called Devin. So I'm going to be using that. And once I have my result, I can, for example, print the not solution. This is called output. And let me just run that, make sure that my app runs remotely. All right, and I obtain my solution. So that means that our app is running, and I can check that run here in the runs table. We can see all the options that we used, the input that was sent, and the result that I obtained, which is my solution. So yeah, this is the apps from models experience, which is how to work natively in Jupyter Notebooks to be able to push those models and turn them into apps. Thank you so much. Till the next one.